Hey, hello friends. Okay, so I'm starting this series as a big data interview questions, and my name is Sampada. Okay, so you will get means we I have listed some of the interview questions that are most important, and I'm guarantee you definitely you will get some of the questions in your next interview. So whatever, like you are fresher or you are someone like who has two years of experience or 3 years of experience, definitely you will face this type of questions in your interview. Okay, so let's start with our first question. Okay, so first one is what is the broadcast join? Okay, so in the as you know, in the Spark, firstly we focus on the optimizations. Okay, and when you are working with the Spark project, you will definitely have different kinds of join operations that you will perform on day-to-day basis. Okay, so in that, most important one is the broadcast join. Okay, so in the broadcast join, what we have like where we perform broadcast join. Okay, so when we have one smaller data sets, okay, one smaller table, and we if we have some larger data set like a larger table. Okay, and what we do, whatever the smaller data set, we broadcast to all our worker nodes, and that broadcast means all the worker nodes have the smaller data set copy. Okay, and that's mean we can broadcast it that smaller data set to our all the worker nodes. Okay, so I have list down the points also. So in the broadcast join, okay, so that is the one of the smaller data sets is broadcasted to all the worker nodes in the cluster. Okay, and reducing need to shuffle. So when we perform any optimization, okay, so first need is to reduce the shuffle operation. Okay, and redistribute the entire data set. Okay, so that's the first need. Okay, so that's why we perform the broadcast join, and this helps in minimizing the data transfer. Okay, so broadcast join will also help to minimizing the data transfer, because what we have done, in the same partition we have broadcasted all the smaller data sets. Okay, and on whatever the larger table we have, it is in the one of the partitions that available in that partition table. Okay, so what we are doing, we are reducing our shuffle operation. Okay, and we are kind of doing some optimization here, so that lead to our faster execution of the time. Okay, so okay, so I will go to the next question. Okay, so this is the most important question. Most of the time interviewer asks this type of question. So what is the difference between flat map and map? Okay, so first one is what is the both are map and the flat map, both are the transformations, and that is the narrow transformation. So this is the similarity between them. So in the map transformation, what we do, the map transformation is applied to each and every element of the collection. Okay, and it produces the new collection of the same size. Means if we have m size of the data, okay, so it will produce same as m size of the data in the output. Okay, so it retains the same structure and the input collection. Okay, so understood. If we have m input rows, then it will out in the output we also get the m output rows. So that is the map transformation. And in the flat map transformation, also applied to each and every element of the collection. Okay, but what it do, it just flattens the result and it can produce the collection of different size. Means if we have m input rows, okay, so it will produces different types of sizes like n plus 1, like that. Okay, so that I have mentioned in this as it's each element can be mapped to 0 or 1 or multiple elements. Okay, so this is the map and flat map. So okay, so third question is the what is the offset of okay, so guys, I have listed all the questions randomly. I have not put down the topics. Okay, so if I get the huge response in this session, so I will also put some topic wise questions that will help you to crack your next big data interview. Okay, so third question is what is the offset in Kafka? So one of the best product company that I have interviewed, that that interviewer asked me this question. Okay, so in the Kafka, offset is a unique identifier, okay, that associated with each record, okay, in the partition, like each partition of a topic, okay, represents the position of a consumer in a particular partition. So whatever the consumer reading the data, it represents the position of that consumer, whatever it was reading the data previously, okay. So consumer, what it's do, it's keeps the tracks of messages it has already processed, okay. The offset is crucial concept, okay, so ensuring that each message is consumed only once and in the correct order. So consumer, what it do, it just maintain the track of all the messages, okay, and it ensure that each consumer will consume only once, okay, and also it make sure that it will consume in the correct order, okay. Offsets are managed by the consumer and they are play key role in providing fault tolerant scalability. Okay, so if there is any if it is any downside of the cluster or something, that means it can recover from the fault tolerant, okay. So with the help of the offset, what we do, it provides the fault tolerant and scalability, okay. So let's consider next question. What are the benefits of Scala language in the big data? Okay, so also this question is very important if you are giving interview with the Scala and Spark, so you definitely get this question, okay. So what are the benefits? Okay, it's a conciseness and expressiveness, means Scala language is a functional programming, okay, so it's a concise language, okay. So that's the very much benefit with this Spark, okay. So yeah, second one is a functional programming. So uh, Scala works on functions, okay. It is a purely functional oriented language, so that's the main benefit that we can get from our Scala, okay. Compatibility with Java, okay. So yeah, in the Scala language, like we can have some objects creation and all that we resemblance with the Scala language, okay. So concurrency and parallelism, yeah. What is in Spark, what we focus, like we focus on the concurrent and parallel object execution. So yeah, Scala language provides this, like it's execute our tasks in the parallel, okay. So immutable collection, so yeah, immutables means we cannot change the value of the collection, yeah. So Scala language provides this functionality, like it's a they there we have immutability collection. So yeah, in soon I will also release some videos on the Scala language, so in that we cover each and every topic, okay. So Spark programming language, okay. So Scala itself, okay, so sorry, Spark itself is written in the Scala language, okay. So that is the benefit we get with the Scala, and it's a type safety, means whenever we are converting our data, means in the program, if we are converting one type to another, it provides us the type safety, okay. So let's consider next question. Okay, what are the benefits of RDD in Spark? Okay, so what is the RDD? Firstly, we check that RDD is a resilient distributed data set. Okay, so RDD is a fundamental data structure, okay, in Spark, that represents a immutable distributed collection of objects. So what is RDD? RD, resilient distributed data set. So it is a data structure and it works on the lower level application, and it is a so we cannot change the value of the RDD, so that's why it's immutable and distributed. So we can distribute our RDD, and we can work with the RDD in the parallel basis, okay. So this is the main feature of the RDD. It's a resilient distributed immutable, lazy evaluate and caching, okay. So these are the special topics in that, but I will answer it in the one go, okay. So resilient means we can reach if there is any fault or tolerance, means if there is any failure, we can easily regenerate from our previous RDD our new RDD. Okay, so that is the resilient. It is a distributed, so we can distribute our RDD into the different class into the different partitions. Okay, so that is the distributed. Immutable means we are not able, if we are declared RDD, then we cannot able to change that value. Okay, so we need to if we want to do some operations on the RDD, so what we do, we then we perform different operations on the RDD itself, and we regenerate the new RDD. Okay, so lazily evaluate means after the action is encountered, then it will perform all the operations. Okay, up to that it just mark down all the steps, and it not perform anything. Okay, and last one is a caching. Okay, so caching is a very basic concept, so where we frequently use data we cache in our memory. Okay, so that is the catching also, it's a vast topic. Okay, so I will also release some videos that where we discuss catching. Okay, so okay, move on to the next section. What is the term resilient mean in the big data? Okay, similar to the previous question where means if we are using some interviewer ask us to what is the RDD in this Spark, with similar type of question, it will be asked like what is the resilient term means. Okay, so it's the ability of the system to withstand failure and continue and processing data and recover from the fault. Okay, so from the resilient it means that we can easily recover our faulted data. Okay, so that's the fault we can gracefully and ensuring the reliability and continuity of the data processing task in the distributed environment. So it will for fault if there is a fault in the RDD, it will just gracefully recover from that fault, and also it will perform next operations. Okay, and continue the distributed execution. Okay, okay, so next question is what is mean by shuffling in MapReduce? Okay, so most of the time MapReduce questions you will not get, but if you are going to some product based companies, then definitely you will get this type of question. They will check the your knowledge on the MapReduce also, because from the MapReduce we are getting some functionality in the Spark. So yeah, we need some basic knowledge on the MapReduce. Okay, the shuffling term refers to the process of redistributing data across the nodes of a cluster. Means what we do, we have so many nodes. Okay, so in that we are shuffling our data from our one partition to the other partition, or we are shuffling our data from one node to another. That is what we call the shuffling. Okay, okay, shuffling is a crucial operation in the distributed computing frameworks, and that is Apache Spark. Okay, so what is the key points in the shuffling? That we redistribute the data. Okay, performance impact when we are shuffling, yeah, you know right? So when we are doing some shuffling operations, there is a huge distribution. It means we are shuffling one data to other, and there are vast types of operations are performing, so there is will be the performance impact. Okay, so transformation boundaries, sometimes we cannot able to do shuffling in the outside of cluster, or some we if we have some boundaries. Okay, so we cannot transfer our data from our one partition to the other. Okay, so that is the key points. Resource utilization, when we are doing shuffling, so many tasks like 200 plus tasks are created in our Spark job. So there are so many resource that we gain for that to do that particular job. Okay, and partitioning means partitioning is also one of the topic in this Spark, where we partition our data. Okay, so based on the similar values, so that is what the partitioning is. So yeah, when interview asks about the shuffling, so you can tell about these key points, and you can explain the term. Okay, so next question is the what is the block size of HDFS, inits and replication factor? So this is the simple question, but so many times we get confused. Okay, so HDFS block size is fixed and it's a 128 megabytes. Okay, and the replication factor means if we are in, if there is any fault, okay, in our failure in our Spark job, or any node is not working. Okay, so what our Spark is do is replicating our data. Okay, so it's storing our data in the different tracks, and with the replication factor of 3 means it stores our, if we have one file, it will make the copy 3 times. Okay, so that is what the replication factor in the HDFS. Okay, so we will move on to the next question. Okay, so what is the cache and persist in the Apache Spark? Okay, so both cache and persist are the methods, okay, to store the intermediate data. Intermediate data means frequently used data, okay, in the memory, and reducing the need to recompute that data. Okay, so means if we are using that data frequently, so Spark, what it do, it will just store that results in the cache, and we can just use that cache in our further Spark program execution. So what is the cache? Cache method is used to persist an RDD or a data frame in memory. Okay, so what is do, it will catches the data, means it will store that data whatever it has means if we have performed some computations, okay, and we got some result, so it store that result in our memory. Okay, so memory it will store, and we in the frequent our in the frequent program, so it will use that cache, it will not again recompute that results. Okay, so that is what the cache. And what is the persist means, in the persist we store the data in the disk. Okay, the persist method allows you to specify the different storage levels and options for caching. You can choose from various levels. So if you are want it only in the memory, means in the persist we can uh, give the different options like memory only, disk only, memory and storage. Okay, so that is how is persist. Cache and persist both are work in the similar way. Okay, but in the persist what we can provide, we can provide the different option for the caching. Okay. Okay, so next question is what is the data frames? Okay, so that is the very basic question, but yeah, one of the company based IT company I have got that this question. Okay, so data frame is a distributed collection of data that is organized into named columns similar to a table. So we can make our understanding like a data frames is a similar to a table, and that is consist of named columns. Okay, so data frame is a fundamental abstraction, okay, so providing high level API means in the Spark low level API is RDD, and the data frame is the high level API. Okay, so that, and what we use for this, it's used for the most of the time distributed data processing. Okay, yeah, so I think I have done with my questions. So yeah, I will surely uh, I have so many questions, and I have so many topics with me. Okay, so I'll surely release one by one. So yeah, do subscribe my channel. Yeah, thanks for your time. Okay.